Good. Afternoon, folks. This time around, I'm coming with applications of AS and A-level mathematics, where we are covering the statistics component. Now, the topic of interest is normal distribution. So let's have a look at what we have. All right. Under normal distribution, it's important to understand the properties. And when we say properties, I'll just write the picture that this is a curve which follows this type of distribution where the mean mu is equal to the median, it's equal to the mode. So we have normal distribution. So here we'll be saying this is our mean mu. Now, if it's standard, then it means our mean mu will be equal to 0. And when we are writing a normal distribution, this is a distribution that follows mean 0 and standard deviation 1. Then we say it's normal. Then standardizing the normal distribution, in other words, we have scenarios where our mean mu, if it happens that it's not equal to 0, then we try to shift so that we put it in a position where mean mu is 0. Then we use tables to find the probabilities. So we can do the inverse. If we are given the probabilities, we want to find which point actually gave us that probability. Then we apply normal distributions to real life context. Let's have a look at what comes below. Still notes, a bit of notes. We were saying mean mu, standard deviation. So this is a distribution that will represent in this format that we need mean mu and variance there. Then we say it's standard deviation. And some of the properties symmetrical about the mean. And like I said earlier, mean equal to median equal to mode. A bit of some, we say calibrations where we are saying within one standard deviation, we have 68% of the values, two standard deviation, 95, it keeps on increasing as we increase the standard deviation. So a bit of some examples there. We're not worried about the examples. What we want actually is to see if we can solve problems using the concepts that we spoke about earlier. So I'm going down to the questions which we'll address promptly. So let's see. The first problem that we have here is we have a normal distribution where we have mean 40. It's not 0, so we need tables there. So find probably that x is bigger than 47. So we need a sketch to say this is a distribution where our mean is 40, but somewhere in front we have 47. So we want chance that x is bigger than 47. So if x is bigger than 47, it means we want this region. But remember, our tables, they calculate the probabilities from the mean to the right, not to the left. So we have to try and think about, was this graph is symmetrical? So rather, what we'll do is we can only compute these probabilities, because that's not what we want. So we need to remember that whatever we get, we'll separate it from 1, then we get the blue part. So let me start to say probability that x less than 47. We are going to say this is equal to, when we standardize it, it's x, sorry, no, our x is known is 0.47. So we're going to say, as we standardize, that's 47 minus the mean 40 all over the standard deviation, which is 5. And this will be equal to, let me bring my calculator now, it's 7 over 5. So 7 divided by 5, it gives us, it looks like 1.2. Let's check, 1.4. So the moment we are looking for the probability, we'll bring a new symbol phi. So it's phi of 1.4. I need my tables to find the actual probability. So if I look for 1.4, 1.4, let's see if I can bring my pencil there. We want to highlight the probability of interest. Is this one, which is 0.9192. So I have 0.9192. So it's going to be 1 minus 0.9192. Remember, we are saying 1 minus because we want the blue part. So if I bring my calculator, it's going to be saying 1 minus 0.9192, giving us a probability of, in decimal form, is 0.0808. 0.0808. That's to 4 decimal places. That's what we have. Moving to the next, which is number 2. It's a similar problem, but what's important is the sketch. Let's have a look at the sketch. We are saying it's a normal distribution according to the description there. So I've got 120. Now, if I check here, my 100 is before 120. Like we agreed, we only find the probability to the left of a point, but the tables, they start from the mean to the right. In other words, our tables, they'll start from here going to the right. Then what do we do? First thing first, we need to standardize. And when we are standardizing, this is going to be probability of, as we standardize, it's 100 minus 120, because we're trying to shift to the mean, all over the standard deviation, which is 18. And when we do so, this gives us, let me try and do the simplification. It will be, it's 20 over 18, because I've got 100 minus 20, so it will be 20 over 18. So 20 divided by 18, it gives us, let's check in decimal, it's 1.11. So I know I'm having, it's going to be negative because 100 is smaller than 120, so it's 1.11. And remember, this is now 5 because we want probability. And when this happens, I think we pick it from the tables. If I go up to the tables, they are going to show me that whenever I want phi of a negative value, check this point that I'm looking at. Phi of a negative is 1 minus phi of the positive. So if I come back, I'm going to now say, but this probability, according to the usage of tables, is going to be 1 minus phi of the positive 1.11 military cares. So if we go back to our tables, we are interested in 1.11. So there is 1.1. I'll need a pencil here to say, but 1.11 is here. And remember, there's also another 1 here, another 1 and 1. Let's have a look at what's happening up there. Yes, it's all okay. I don't think we needed all that. I don't know why our table is split into all these sections. So all we need is that one. So remember, we've got 0.8643, but this, according to decimal, this part is as good as 0. Let's see, 0.002, because here I've got 4 digits after the comma. So in reality, it's 0.8645 when I add this. So 0.8685. Let me come back and say, but this is equal to 1 minus 0.8685. And when I bring the calculator, it's 1 minus 0.8685, giving me a probability in decimal of 0.1315. So my final answer here is 0.1315. Moving to the third problem, I have got another normal distribution question. This time around, I've got 2 bounds. So if I draw my sketch, I have a scenario like this. Well, this is my mean 80, but I've got a point of interest 60 and another 100 there. So my area of interest is in between those points. So that's the shaded parts. Now, if I check carefully, I look at the difference between 60 and 80, clearly tells me it's 20, even here is 20. So it looks like these points are symmetrical. So when that happens, I just find twice the number of the bigger value minus 2. In other words, I'll say, let me standardize. Probability of it's going to be 100 minus 80 all over the standard deviation here, which is 12. And when I come to my calculator, it's 20 over 12. So if I bring 20 divided by 12, actually it gives me 1.666, I think. So it's 1.67. So I can come to say, but this is phi of 1.667. But remember, it's symmetrical. So we are going to be forced to say, but twice this phi of 1.667, then we subtract everything from 1. It gives us our probability of interest. Let me bring my tables to check 1.667. Let me try and push up 1.667. So 1.6 is here. So 1.66. So 6, because it looks like we start from 0 there. So it's 1.6. Let me bring my 2, 3, 4, 5, 6. Then I go to the 7. But these ones, they start from 1. So it's 1, 2, 3, 82, 0.9512. It gives me 0.9522. So I'll come here and say, but 0.9522, if I want twice of this, it gives me this result in decimal, which is that. But when I subtract everything from 1, my result now is going to be 0.9044. So what I know is when I simplify, my probability is 0.9044. 94 9044 9044. Still proceeding. I want certain value x, certain value x. So this time around, I'm given the probability, but I want the value which gave us such a probability. So there we are. Our mean is 30, but we are saying x is less than a certain value, but it gives us a probability of 90. But remember, the symmetrical part, it gives us a probability of 0.5, implying if we say x is less than a certain value x, it means we are interested in the area to the left. If it's 0.9, it means our x actually is supposed to be somewhere there. Then what do? We are going to say, all right, when we standardize, is x minus 30 all over 4. This is equal to 0.9. But when we bring in the phi of x minus 30 over 4 is equal to 0.9. Then we go the inverse to say x minus 30 over 4 is equal to arc phi, which is inverse phi of 0.9. So what do we do with inverse phi? We're going to go to the tables and try and check where we get 0.9 or a probability of 0.9. Let's try and check 0.9. Let me bring my pencil so that we try and pick. Here I've got 0.8989 or 899, 0.9. So it looks like we're interested in this part. But let's check, it's 8997. So we need to add that fourth digit so that we reach 0.9. So maybe a 3 was short there, but we'll go for the smaller one. So if I try to pick, it's 1.2 here. So I'll count 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's 0.1281, 0.1281, 0.1281. So if I move, I have got 0.82, 0.1281. So this is 0.1281. That's x over 30 over 4. Therefore, x minus 30 is equal to 4 multiplied by 1, I mean 0.1281. So my x is actually, let me try and raise for space, is actually 30, sorry. 30 plus, what's that now? 4 times 0.1281. Let me try and simplify with my calculator to say if I push it this side, I've got 30 plus 4 multiplied by 0.1281, which will give us